So here is another question. It has been given that two cars A and B are moving along parallel paths from a common point in a given direction. If u and v are their speeds or velocities because they are traveling in the same direction, straight line. So if we say that u and v are their velocities, it will not be wrong. Okay, still their speeds are u and v with u greater than v. The velocity of car A is greater than velocity of car B. Then find the separation between them, the distance gap between them after a particular time t. Okay, so it is a very important concept related to relative velocity. So let us try to understand this. Let us say we have two cars. Okay, this is one car, car A. It is moving with velocity or speed u, and we have another car B. It is moving with a velocity, speed v. Okay, this, let's say it is u kilometer per hour, this is v kilometer per hour. So after, let's say, 1 hour, okay, after 1 hour what will happen? This car A, it will have covered a distance u. Okay, this is after 1 hour. Okay, and this car B, it will have covered a distance v kilometers, because the speed is u kilometer per hour. So after 1 hour it will have covered u kilometers, this will have covered v kilometers. The gap between them is u minus v kilometers. Okay, this. Okay, this is u minus v kilometers. Similarly, after another 1 hour, it will have covered another u kilometer, and this will have covered another v kilometers. Okay, and then the gap between them will be equal to 2u minus 2v, which is equal to 2 into u minus v kilometers. Okay, after 2 hours. So like that, after every 1 hour the gap will increase. Okay, so here this is a very important concept related to it. So when things like that occur, you have to take relative velocity concept into play. Here, as both the cars are traveling in the same direction, okay, we have to consider the relative velocity between them. Okay, relative velocity between them. Here the relative velocity is equal to u minus v kilometers per hour. Okay, u minus v kilometers per hour. So when we take this u minus v relative velocity concept into play, we know that distance is equal to velocity into time. So here, as we are considering the separation gap, okay, the separation distance or the separation gap between A and B, it will be the relative velocity between A and B multiplied with the time, okay, the duration for which we have taken the observation. So here it will become the separation gap is equal to the relative velocity u minus v kilometer per hour multiplied with t hours. This is the separation between A and B. Thus gap or separation between A and B. This. So here, as you can see, in this case, when both the cars are traveling in the same direction, it's very important, when both the cars or vehicles or bodies or objects, whatever, they are moving in the same direction, in that case, relative velocity between them, it will cause increase in the gap. The gap will increase, keep on increasing between them, and it will increase with respect to the velocity difference or the relative velocity, that rate. Here the gap will increase at a rate of u minus v kilometers per hour. Another interesting case, suppose we say we take two objects or two bodies or two vehicles which are moving towards the same direction, the opposite direction. Okay, here let's say it is moving at a rate of u kilometer per hour. Here another vehicle or car is moving at a rate of v kilometer per hour. Okay, so in that case, the gap between them, let's say the initial gap between them is d. So after 1 hour, this vehicle, it will have covered, a distance of v kilometers, and this vehicle, it would have covered a distance of u kilometers. Now the gap between them has decreased by a value d minus u plus v. After another 1 hour, it will have covered another v kilometers, it will have covered another u. Then the gap will decrease by this much. Then after 3 hours, it will be d minus 3u plus v. Then after n hours, it will decrease by d minus nu plus v at the nth hour, for the nth hour. So here, when both the vehicles are traveling in the opposite direction, the relative velocity, we know it is u plus v. I have already discussed that, u plus v kilometer per hour. And here, when they are traveling in the opposite direction, relative velocity causes a decrease in the gap, and that occurs at a rate of u plus v kilometer per hour. In the same direction, relative velocity causes an increase in the separation distance. In the opposite direction, relative velocity causes a decrease in the separation distance. Okay, ultimately they meet at a particular point. Suppose both the drivers are wise enough to apply their brakes, an accident or collision will be avoided, otherwise God knows what will happen. Okay, but still this is the case. Okay, this is an interesting concept. So this question can be given in a variety of forms. It can be said to trains, to cars, to objects, to bodies, they are moving in the same direction, opposite direction. Some values of their speeds or velocities will be given, and then you can use these two concepts, whether they are traveling in the same direction or opposite direction, to find out the result. Okay, so always remember these two important things. First this, then this. Okay. So here is another question on relative velocity, again involving trains, their movement. So here the question is that two trains traveling along the same straight rails are moving with a constant velocity of 60 km per hour, the first train, and the second train with a velocity of 30 km per hour towards each other. Okay, that is in the opposite direction. And let's say at a particular time where the observation started, it was given time t equals to 0. The distance between them is 90 kilometers. Find the time when they will collide. Okay, so let us try to understand this question. Okay, so here we have two trains. That traveling in the opposite direction. This train, let's say it is traveling with 60 kilometers per hour, and this train, another train, is traveling with a velocity of 30 kilometers per hour as it is given. Okay, and the point where this observation started at time t equals to 0, the gap between them, the separation between them is 90 kilometers. Okay, this is the separation distance. So as they are moving along the same tracks in the opposite direction, so naturally there will be a collision, okay, at some point of time. So here the concept of relative velocity will be used to determine at what particular time this collision will take place. So here the relative velocity of approach between these two trains is equal to, okay, relative velocity of approach as they are moving in the same direction. It will be 60 kilometers per hour. Okay, again an important thing is to put the sign. It is moving towards the right. As I have already explained, everything towards the right, towards upward side, it is positive, downwards and left are negative. This is moving towards the left, so that is why it is negative, minus 30. So here I am taking the relative velocity of approach as the relative velocity of this train 1 with respect to 2, with 2 as the reference. So it will be 60 minus 30 kilometers per hour. So this will be 90 kilometer per hour, the relative velocity. The total distance that both the trains have to cover is 90 kilometers. Total distance is equal to 90 kilometers. So the time taken for both the trains to undergo collision, okay, for collision is equal to distance by relative velocity, 90 kilometers per hour, which is equal to 1 hour. So if we try to understand this, first this train traveling with 60 kilometers per hour in 1 hour, it will cover 60 kilometers, and this train moving with 30 kilometers per hour in 1 hour, it will cover 30 kilometers, and they will meet here. Okay, they will undergo collision at this point, which is around 30 kilometers to the left of this point and 60 kilometers to the right side of this point. Okay, this was point 1, this is point 2. The collision will take place at 30 kilometers to the left of point 2 or 60 kilometers to the right of point 1. Okay, this. Okay, here. Okay, so this is the solution to this question. The time taken for collision is 1 hour. Okay.